Hello, friends. I'm going to talk to you about our beloved Earth, the blue planet. We keep debating about various environmental issues. All of us talk about global warming, etc. But the truth is, we have never physically experienced the grotesque situation of fiery balls of fire, solar winds, and fluctuating climate, and all those oscillations during Ice Age and interglacial period. The tumult and the magnitude of changes that Earth had to undergo to reach its present state is beyond description. Do you know? Geological timescale is a record of the Earth's history based on the rocks and the organisms that lived at different times. Geological timescale is like a calendar for events in the Earth's history. It subdivides all times into named units of abstract time called eons, eras, periods, epochs, and ages. Thus, the four major divisions of time scales in geological time are eons, eras, epochs, and periods. How do we read a geological time scale? The largest blocks of time on the geological time scale are called eons. Eons are split into eras, and each era is divided into periods, and the periods may be further subdivided into epochs. Coming to eons, the eon is the broadest category of geological time. Earth's history is characterized by 4 eons, and in order from oldest to youngest, they are the Hadean, the Archean, the Proterozoic, and the Phanerozoic. Collectively, the Hadean, Archean, and the Proterozoic are informally referred to as the Precambrian. Cambrian period refers to the beginning of the Phanerozoic eon, so all rocks older than the Cambrian are Precambrian in age. These Precambrian eons tell the story of Earth's beginning, life's origin, and the rise of complex life. Now, the eons of geological time are subdivided into eras, which are the second longest units of geological time. Eras are defined based on the fossil life forms found in the rock layers and the law of superposition. We have to understand that the Hadean, Archean, and Proterozoic eons do not have recognized eras. The Phanerozoic eon, the span of geological time extending about 541 million years from the end of the Proterozoic eon to the present, is called the eon of visible life. The Phanerozoic eon is divided into 3 major spans of time or eras based on the characteristic assemblages of life forms. The 3 eras are Paleozoic era, Mesozoic era, and Cenozoic era. Just as eons are subdivided into eras, eras are subdivided into units of time called periods. The Paleozoic era is divided into 6 periods. Let's see them from oldest to youngest. 6 periods are Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. The Mesozoic era is divided into 3 periods: the Triassic, Jurassic, and the Cretaceous. Cenozoic era is also divided into 3 periods: the Paleogene, Neogene, and the Quaternary. Periods of geological time are subdivided into epochs. In the Paleogene period, we have 3 epochs: Paleocene, Eocene, and Oligocene. In the Neogene period, there were 2 epochs, the Miocene and Pliocene. And in the Quaternary period, Pleistocene and Holocene. The Earth has existed for 4.6 billion years. The geological time scale divides all those years into sections. Each section is unique because it shows a specific change in life or in the Earth's surface. If we could rewind time and time travel is possible and we walk into the past, we'll be surprised to note that Earth was not a blue planet. Temperature was hot with lava flowing. Asteroids and comets pelted Earth. In the Hadean Eon, we find that the Big Bang and the solar winds swept hydrogen and helium closer to the Sun. The Sun could not pull heavier elements. They spiraled and settled to form planets. Earth also coalesced from a cloud of dust into a planet. Heavy materials like zinc and iron sank to form an inner core, and lighter materials remained on top, meshing together to create a crust. Hadean Eon is marked by three important events: the heat source, magnetic field, and moon formation. The heat source was established with the Sun. The magnetic field was formed, and this was the first step for life to persist on Earth. The solid inner core heats the outer liquid layer. It produces convection current. This geodynamo is Earth's magnetic field. In the Hadean Eon, Earth's magnetic field was just developing. It started deflecting solar winds, making Earth more habitable, and without it, Earth would be exposed to Sun's deadly rays. Humans did not exist and could never ever have thrived even later. Next important event in the Hadean Eon was the formation of the Moon. An object headed towards Earth at tremendous speed. It did not hit Earth directly, but grazed the sides. Earth's gravity pulled the Moon into its orbit. The formation of the Moon had profound effect on Earth's climate. It slowed down its rotation, tilted Earth on its axis. Earth started to have seasons. Moon stabilized Earth from wobbling. Balanced climate developed on Earth. At the end of Hadean Eon, Earth was still in the late heavy bombardment stage, and asteroids and comets pelted Earth. Thus we understand in Hadean Eon we obtained the heat source, the magnetic field, and the Moon. There are no fossil records as temperature was too high to sustain life. The Archean Eon is the second of the four geological eons of Earth's history, representing the time from 4000 to 2500 million years ago. This time, Earth's crust had cooled enough to form continents and for earliest known life to start. Life was very simple. Shallow water microbial mats called stromatolites existed. However, there was no free oxygen in the atmosphere. The major events that happened in the Archean Eon was the formation of oceans and continents. Well, when we talk of oceans, where did the water come from? Scientists say that water existed inside the rocks that make up the earth itself. The earth's interior contains minerals with hydrogen and oxygen. Volcanoes continually degassed, releasing H2O as water vapor. The moon contributed to this process by stabilizing the earth's climate and giving it seasons. Archean Eon, the first tectonic activity, helped to build continents. The climate allowed the formation of continents because the lithosphere became more stable. Are always moving. Plate boundaries interact with each other in three ways: the divergent, the convergent, and the conservative. Divergent plates pull apart from each other. Convergent plates push boundaries together, while conservative plate boundaries slide across from each other. These plate tectonics are necessary for building continents. This implies that tectonic activity was present in the Archean Eon. At the start of Archean Eon, Earth did not have free oxygen. Water molecules had oxygen, but they were bonded with hydrogen. Earth's atmosphere was mostly methane and nitrogen. In such an atmosphere, only cyanobacteria existed. It is amazing to note that these microscopic cyanobacteria converted sunlight into energy. They carried out photosynthesis in the oceans, metabolizing their own food. As a waste product, cyanobacteria released oxygen. Over time, free oxygen built up in the oceans into banded iron formation. As oxygen filled the oceans, it mixed with iron. And when iron reacts with oxygen, It rusts, so over time the sea floor collected rusted iron. Most of the world iron ore deposits were produced in the Archean Eon. Oxygen rusted iron in the oceans, and when there was no more iron to rust in the ocean, oxygen entered the atmosphere. This event is the Great Oxygenation Event. Thus, the oxygenation process just started in the Archean Eon. Proterozoic Eon extended from 2500 million years to 542 million years ago. The name Proterozoic comes from Greek, which means earlier life. The well-identified events of this eon were the transition to an oxygenated atmosphere, several glaciations, and evolution of abundant, soft-bodied multicellular organisms. In this eon, the temperature cooled down significantly compared to the Archean eon. In this eon, Earth completely froze into a snowball Earth or slush ball Earth. Atmosphere before oxygenation was filled with methane. One thing that methane did well was trap heat in the atmosphere. When oxygen combined with methane, it produced carbon dioxide. Because there was less methane in the atmosphere, the greenhouse effect wasn't strong. With less heat trapped in the atmosphere, Earth froze. Earth is unique because of ozone layer. It is essential to life on Earth because it protects us from harmful radiation from the sun. The oxygenation event, oxygen atoms could bond and form ozone. Over time, Earth's ozone layer thickened in the upper atmosphere. Earth had the right condition to support life. In this eon, there is evidence that eukaryotes and multicellular organisms appeared on Earth. In the Proterozoic eon, Earth froze into a snowball, ozone layer thickened, and multicellular organisms evolved. The Phanerozoic eon is the current geological eon. It began approximately 541 million years ago. It began with the Cambrian explosion, which was the massive biodiversification of multicellular organisms. The Phanerozoic eon is divided into three eras as we know: the Cenozoic or age of recent life, the Mesozoic, age of middle life, and the Paleozoic or age of ancient life. All these eras have been named in accordance with the sequence of life developing over the eon, starting with the earliest bacterial life forms and marine organisms, followed by dinosaurs and early mammals, through to human beings and other modern animals. The major events that have occurred periodically throughout the Phanerozoic eon are mass extinction event, major glaciation event, magnetic pole reversals, changes in climate, changes in sea level. Mass extinction events are events when large numbers of species die. There have been 5 major extinction events and several smaller extinction events too. The big 5 mass extinctions are the biggest disasters in the history of Earth. The first mass extinction was in the late Ordovician, the second in late Devonian, the third in the Permian, the fourth in the Jurassic, and the fifth in the Cretaceous period. The next major event was the major glaciation, which caused global cooling and decrease in sea level. The major event was the magnetic pole reversals. Can you imagine? The magnetic poles of the Earth switch on an irregular basis, with North Pole becoming South Pole, then switch back on the next reversal. What a devastating experience it would have been. Changes in climate is also one of the major events that took place. Earth's climate shifted between hotter and cooler, drier and wetter throughout its history. It's interesting to note that supercontinents were created when majority of Earth's land masses came together as a single unit due to plate tectonics. Two major supercontinents occurred during the Phanerozoic eon, namely the Gondwana and the Pangaea. Here's an interesting analogy which I read: GTS as a calendar. Geological time began ticking when Earth formed 4.6 billion years ago. Scaling this large amount of time to a calendar year, each of the 12 months of the geological calendar year represents 383 million years. Generally, each year has 365 days, so each day represents 12.6 million years in geological calendar. Each day has 24 hours, so 1 hour represents 5,25,114 geological years. Each hour has 60 minutes, so 1 minute represents 8,752 geological years. Finally, each minute has 60 seconds, so each geological second represents 146 years. Amazing, isn't it? Dear friends, the history and mystery of our earth and birth leaves us flabbergasted. How much of struggle has taken place to make our planet habitable? How much preparation has been made for billions of years so that we could thrive on earth today? No one knows the purpose behind creation. A peep into the past emboldens me to say that our delicate planet is a gift from God. It is our duty to contribute towards a noble cause of protecting our earth for the future generations. The journey of our beloved earth is unending, may I say? Men may come and men may go, but the earth goes on forever. More species may evolve in the distant future. Earth's transit continues. There are more eons and evolutions to come. Friends, let's create an eco-friendly lifestyle to make Earth habitable for the future generation and species. Dear friends, I dedicate this video to my beloved departed father, Mr. P. Chandrasekhar. He was a mining engineer, consultant, geology and mining and mineral services. He rendered excellent services in Kolar goldfields. He was adored by his crew and workers and fondly called Captain and also the Tiger of KGF Mines. Throughout his life, he explored the mines and quarries of earth. Now I believe that he is exploring the heavenly bodies from his heavenly abode. He was a proud recipient of the Leading Scientist of the World 2011 award conferred by Cambridge University and the Vikasathan Award conferred by the Economic Forum. He also worked in Dalmia Cements and after his retirement as a vocational instructor in Taman Mines, Trichy. I hope to share more about his experiences. Dear friends, there are many more aspects to explore, learn and relish. The journey is never ending. Stay with me. Please subscribe, share and support. Thanks for watching.